Hello everyone again and welcome to Python Tips. So today we'll be looking at a very important library in Python called Numpy, which is mostly used for numerical computations. Numpy provides support for arrays, it provides support for matrices, and also provide a collection of mathematical functions to operate on these different data structures. So why is NumPy very important? Because it's efficient for storing and manipulating numerical arrays. Is this a faster way of doing computations using vectorization? And it's also very essential for scientific computations, data science, as well as in machine learning. Now, before we can create a NumPy array, we have to import that library, as I did mention, and then we do an alias as NP. We are doing this aliasing because we don't want to be calling NumPy all the time, but if we do alias, we use a shorter word or anything we can think about. You can use N, you can use P, whatever thing you like. Now let's start by creating our first array. Let's think of this array as what? As like a vector that we have in mathematics. Now, if I want to create maybe like a vector, I'll just do np dot a array. So there is a way, most of the times, you don't want to think about this. You can just start typing A, and then you use the tab key on your keyboard. It will give you different options. Remember, ABS here means the absolute value. You can do addition, but what we are looking for is what? That array. So let's scroll down, array. So what we are looking for is, where is the array? We can just even type arrow, a range, another arrow, and then we pick that array. And then, so it will simply give us something like a vector. Now, if I want something like a multi-dimensional array, which we can think this like a 2x2 matrix, we can also do np.array, and we already saw what a list was. So if you want to create any array, you put elements in that np.array in form of what? A list. So also there are built-in functions we can use for NumPy. Maybe if I want to get maybe an array made up of zeros, this one here simply I'm getting a matrix, which is what? Made up of 2 rows and what? 3 columns, all zeros. I can do np.ones, where I need a matrix that it has 2 rows and what? 3 columns, all made up of ones. Maybe I need a vector by generating a range of numbers from what? 10 to what? To 49. Now, line space a lot is used in generating. Maybe you are plotting a graph and you want to maybe scale both axes of that graph. You can use this. You can also use this in binning elements. Maybe you want certain range of elements to be in a particular bin, as we will see. In Python, you can do what? np dot what? Line space. Now, if we print all of this, you are going to see, for example, let's go to the cases of np dot zeros. We will see that we have a 2x3 matrix all made of what? Zeros, like in the case of ones, as we see. Now, the line space is generating numbers from what? 0 to 1 with evenly spaced values. Now, another thing we will have a lot is when we are doing maybe getting the shape of maybe that array that we have. Maybe b.shape here simply means now, most of the times if you create maybe an ND array and you want to shape it to have a particular dimension, as we will see, especially with image processing, we use that array dot shape. So if I do dot shape and maybe pass in the shape that I want, it will give me that array in form of that shape. So here B, the shape of B is a 2 by what? By 2 matrix. Now also you can use D type to get the data types in that array. You can use the size of that array. So if I do size of A was what? A vector with what? 3 elements. That's why you are having the size of A here to be what? To be 3. Now the dimension of B was what? B dot n dimension. It will give me the dimension of that array, which was what? 2. Now, same as we were doing like slicing and indexing elements when we saw list or dictionaries, we can do same for arrays. Let's say I want to go to the array B that I created and I want to extract what? 2. Now, Remember, this array is made up of what? Rows and what? This will be the first row because I print this. I will have the first row as what? In that array as 1, 2, and then the second row as what? Made up of what? 3 and 4. So what I'm trying to do is I want to go to the first row of that array and then extract what? 2. Remember, the same way we're indexing, 1 will be at what? Will be in the first will be at row 1, index what? 0. Then 2 will be at row 0, index what? Index 1. So now I want to extract what? 2. So because 2 is found at row 0 and index 1, that's why I'm using that row 0 and then at index 1, which is giving me what? That element 2. Now, if I just want to get the first row in that array, I can just do b.0. It will give me all the elements in that first row, which is what? 1 and 2. Also, if I want to get the last column of what? That array, which is made up of what? 2 and 4, I can just do b column 0 minus what? 1. The same as we were doing for list if I want to get the last element in the list. Now, we can also do mathematical operations in for ND arrays, or maybe for matrices, or which we term them, this is like vectors, x and y. Now, if I want to add these vectors, I can just do addition x plus y. Because the dimension of these two vectors are same, I can have perform operations on these vectors. The same for multiplication, the same for raised to the power. If I do a print out here, I will see that this plus this, 1 plus 4 is 5, 2 plus 5 is what? 7, 3 plus 6 is what? Is 9. The same as for what? Exponential, the same as we are looking at what? np.sine, the sine of, we have seen sine functions are mostly used for trigonometric functions. Maybe you want to plot the sine of x with y, you can always do that. We will see this as we move to what? Matplotlib. But for now, also we can do the dot product of that vector x and y. And so also we have what we call in aggregating functions, which is like summing, looking for the mean, looking for the maximum value. So let's say if I want to sum all the elements in this N2D array, so if I sum this is like summing all of these, which will be 21. Also looking for the mean, I can look for the mean for all of these, like summing every element here and dividing by what? The total. So it will give me 3.5. Now, maybe I want to look at the maximum values in this ND array, column what? Column wise. So that is why I'm doing np.max data. If I'm looking at it column wise, I will take axis is equals to what? 0. And then in that case, column wise, I'll say the maximum values here will only be what? 4, 5, and what? And 7. And 6, please. Also, I can look at the minimum value row wise. If I look at it row wise, and then I will only have what? 1 and what? And 4. Because here it's like I have a 2 by 3 matrix. Now, we also have what we very commonly use in Numpy, what broadcasting. Let's say, for example, I wanted to maybe perform an operation with an ND array, which the shapes are not the same, with different shapes. So we can use what we call what? Broadcasting, which if I just print this, you'll be seeing that I printed A and B, but if I want to do a broadcast, because the dimension of this array and these ones are different, if I want to do a broadcast, I'll say like 1 plus 10, 2 plus 20, 3 plus 30. That's why we are having the first one here as 11, 22, and 33. Same here, 4 plus 10 is what? 14, and so on. We can also do sorting as well as filtering. So let's say I have this array and I want to sort. Sorting helps us like arrange elements either in alphabetical order or in what? In descending order or ascending order. So for example, I have this array which is what? 5, 4, 3, 2, and what? And 1. Now, if I want to sort these elements to now be from what? 1, 2, 3, 4, and 5, that is from lowest to highest instead from highest to lowest as I have here, I can just do np.sort. And if I print this data, I should be having something like what? 1, 2, 3, 4, and what? 5. Also, I can do same like, see, if I have an array which is made up of what? Fruits, banana, cherry, and apple. We have seen this list before. And I want to sort this array in form of alphabetical order, as I did mention. It should now be in form of what? Apple, banana, and what? Cherry, which we have here. Now we can also do filtering, which is like, maybe I just want to go in this data and I only want those values that are greater than what? Than 3. I will put something like a mask, data greater than 3, and then print filter, data of what? That condition that I want to filter with. If you don't want to put this mask by doing that, you can still do in here, data greater than what? Than 3. We do this most of the time so that, it's easier for you to just name these variables so that when you come in here, if I run this, I'll have the same thing. I'll still have 4 and that's 5 and what? And 4. Now let's go to some of applications that I earlier mentioned, like looking at the distance between 2 points. Now the distance between 2 points, as we saw a lot in mathematics, and we will see a lot of this as we move into machine learning applications, especially clustering, like grouping points together, we will see this distance between 2 points a lot, which is, I mentioned in one of my videos, we call this the Euclidean distance. Let's say I have this point 1 made up of an NP array, like a vector 2 and 3, another vector 7 and 8, and I want to compute the distance between these 2 points using this formula. Now it says that I'm using np dot what? Square root, because like I'm looking at the square root of the sum of the difference between x2 minus x1 and then y2 minus what? Y1. So I'm doing np dot square root, which is taking np, what I have on the square root, into what? np dot sum. What am I summing? I'm summing all these points, taking what? 2 minus 7 all squared minus what? 3 minus 8, and then I'm summing all of these. So meaning that I'll take this, subtract from this, I'll square it, and then I'll take this, subtract from 8, and then I'll square it before I can look at what? The sum. That is actually what this is doing, which is the same like this formula we have above. So if I just do this and bring this distance between 2 points, I'm going to have this. You can try this even with your calculators and see what you get. Now, if I do not want to go through this long process, right? Now, in Numpy already have like built-in formulas, which we call them the R1 num, R2 num, and all the like. Now, because I want to just see this as the Euclidean distance, you can go into Numpy and do what? np dot what? Linear algebra. This is a linear algebra method, which is very common, like looking at the distance between 2 points is under linear algebra. If I just do np.lin dot what? Num, I will pass this point 1 and what? Point 2, and then I can print this distance. You see, this one is a little bit shorter than just writing this entire formula. So if I print this, we see both answers are what? Are same. There is no difference. Also, one other good application we can see is like looking at the inverse of a 3x3 matrix. For most of us that did linear algebra 2, we have seen this. Even in mathematics, whether it's junior and senior secondary school, we see this formula a lot. But how can we simplify this? Let's say we define a 3x3 matrix like this, and then we want to compute one thing. We can look at the determinant of that matrix. This is still a linear algebra method. So determinant np.lin r dot what? Depth of what? A. It will give me the determinant of that matrix. If I want to compute the inverse of that matrix, I can just do np.lin r dot what? Inverse, which is inv of that matrix A, and then I print all of this. We are going to have these matrices. Please, guys, keep following for more of these tips, because we will see a lot of these mathematical operations, especially when we come to machine learning applications, because most data sets are in form of what? Vectors as well as what? Matrices. Thank you so much, guys.